Okay, everyone. Okay, what I will do is, if you allow me, I will be skipping some derivations. Okay, not some derivations, one derivation. Okay, let's go. Come on. Let me try my best that the colors are good. Okay, so last time, if you remember, I left here, right? I said that we will have R equal to, what happened? E caret R. Then I talked about the fact that we have two formulas of velocity. V equal to R theta dot E caret theta and R dot E caret R, the unit vector. And then we said we have A equal to, what was that formula? Anyone remembers? R theta double dot plus 2R dot theta dot E caret theta plus R double dot minus R theta dot square. Does it ring bells, right? E caret R. Oh, come on. E caret R. And yes. Oh, yes. Polar coordinates and radial portion. I will talk about it. I haven't even made the coordinate system yet. Yes. I will talk about it. So what I want from you is to memorize this and memorize this one. And then I will just write these two, which I will not talk about because I haven't gone through the derivations. So you just have to write it in your notes if you want. The day we go over the derivations, we will go through all the chunk minus theta dot ER. Okay, theta dot E theta and minus theta dot ER. Okay, E dot R equal to theta dot E dot. Okay, now let me make the diagram because without any information, it's impossible. So you can see that I have let me do a Control Z. Let me make like this. So let's say this is my coordinate system. Are you following me? Okay, so this is my E caret R. Now the object is going in this direction, okay? Okay, forget about the direction. This is very misleading. I will say that the angle is actually increasing. So for example, how should I explain this? The angle is increasing like this. So that's why I have E caret theta E caret theta in this direction. Okay, so let me write down the English for you. Let me write down the English that says the angular coordinate is in direction of increasing theta when the radial coordinate is kept constant, the E caret R is in direction of increasing radius when the theta coordinate, when the E caret theta, I mean when the theta is kept constant. Okay, I think I need to write the whole English. You have to bear with me. When R is kept constant, and here you will write when theta is kept constant. Okay. I will explain. You have to bear with me, please. I will explain. This is what we will be doing today's class. In fact, 2-3 classes. Okay, just follow me. We have two formulas, one for velocity and one for acceleration. And we are talking about polar coordinate system. Again, you have 90-degree angle between the two unit vectors, the E caret R and E caret theta. What's the purpose of it? Do you remember that pendulum example last time? Everyone does. You remember those two pendulums I created? Okay, I did, by the way. So I will make them again, and then we will start our first problem. 6, 5, 4, 3, 2, 1. So last time, right before the end of the class, I made these two pendulums. I said that this one has a rigid rod. And then I said, give me the velocity. This is the hinge or the pin joint. Okay, this is not good. Let me make it like this. And then I created, oh, come on. This is not even horizontal. Okay. Then I said, make another one, this time with an elastic band. So if you remember, we made something like this. I put a spring. I put a point object again with a mass. Okay. Then I put this fellow pivot. Okay. Then I said that this is length L. This is length L. Give me the velocity and give me the velocity for this case. Then I said, give me the velocity acceleration for this case and give me the acceleration for this case. Okay, do it. Okay. Okay, and this is the theta. And this is theta. For those of you who are saying, what is the length? The length is that when I'm hanging it, so of course, because of the fact that there is a spring, the bob sinks right under its own weight. Once it has sunk, let's say I'm calling that as my length. But then I will give it an initial condition, it will go like 10, 10, 10, right? So give me the velocity for the rigid rod. It will be R theta dot, which is R omega in the E caret theta direction, and 0 E caret R, right? And here I will have R theta. Okay, not R. I think there is L. So that's my mistake. And then I said I will put L theta dot. But the fact it goes like 10, 10, 10 in the radial direction, I will put R dot E caret R. Here I said R theta double dot plus 2R dot theta dot. But I think this term will vanish. E caret theta, and then I added R double dot minus R theta dot square. Okay, and then E caret R. So we all say that this is a rigid rod. So this fellow will be a goner, right? And this will also go away, huh? Then what about this term? I will have, oh, come on, R theta double dot again plus 2R dot theta dot E caret theta plus R double dot minus R. Okay, I think you understand that. r double dot minus r theta dot square e caret r. Okay, hang on for a second. Now just answer me a few questions. Look at this one. R omega. Okay, this one. R alpha, right? Good. So this is from my physics one. Follow the physics one. This is my R omega. Okay, this one is my R alpha. All of you studied the same notations, right? We have okay, R alpha. Okay, because I haven't studied from here. I'm not sure the symbols. R alpha. Okay, everyone is saying R alpha. Okay, anything else? What about this one? R omega square, right? R omega square. Okay, so which one is the tangential velocity? This one, right?
Yes.
Tangential velocity. Okay, which one is tangential acceleration? R alpha. A t. Which one is the normal acceleration? This one, R omega square. Normal. Do you see the? Sorry. No.
Normal means radial, right?
Exactly. I am just connecting the two pieces together so you understand that is what I studied there. Normal acceleration, tangential. Here I am calling it radial, but it's the same chunk now. So just tell me that there is a negative sign here. Are you getting my point? Why there is a negative sign? Because if I ask you, make the coordinate system here in polar, how many agree and how many disagree? I am making this as my e caret r, and let's say in increasing theta, e caret theta. Do you get my point? Okay, make the coordinate system here. Increasing theta, e caret theta. What is the direction of increasing r? Outward, right? So increasing r is in this direction. 90-degree angle, okay? E caret r, okay. Now make a normal tangential coordinate system for me, quickly. Okay, you make it. At the same point, show me normal tangential coordinate system. I just want to see the arrows. So just tell me, you can make like two arrows and just tell me normal and tangential. So okay, you can make one. Okay, make here. Make one arrow here. Yeah, one arrow and one arrow there. Okay. No, this is normal. This is normal. Good. So good. You did it. So this will be normal. This is normal. This is normal. And this is tangential. What? This is normal. This is tangential. Now, my question is, do you see this arrow and this arrow? They are opposite. Okay, yeah, that did it. Okay. So I have asked all the students. This is normal. This is okay. I know that some of you have drawn here. That's fine. Okay. This is not the point of contention. You can make it here. I don't mind. Okay. Then normal here. Tangential here. So normal is towards the center of curvature. Are you getting my point? Whereas radial is in the increasing r direction. So they are actually opposite here. Do you see this negative sign? This is the reason that the maths is telling you that you are very happy that you have got normal acceleration. Just remember that this is negative of normal acceleration, because all this while you have been talking about the fact that the normal acceleration is pointed towards the center of curvature. Are you getting my point? So I'm just combining two pieces together from here onwards. Okay, why don't you tell me the names here? So this is r omega, done. Okay, what about this one? This is your radial velocity. That's fine. You can call it as radial velocity. Okay, what about this one? No, r. This is theta double r alpha. Okay, this is tangential. This is r omega square. Again, you identify this as normal acceleration from your physics one. This one is, okay, let's not get into the physical meaning of this. Next time I will explain, or probably I will also bring some YouTube video. Just name it here and we will talk in detail. Okay, it's even pronunciation is difficult. It's Coriolis acceleration. Coriolis. I'm definitely doing a bad job in pronunciation right now. It's Coriolis. Okay, and this is L double dot. L double dot. What is the name of this one? Oh, no, let's not call it as radial, because when I tell you radial or angular, let's go back. When I ask you radial or angular, this chunk is angular. This whole chunk is radial. Okay, so let's not call the individual component radial. L double dot is L double dot. I right from the top of my head, I don't even remember the name for it. It's R double dot. So far so good, right? It's nothing, it's clear. Okay, now I know that you want me to make a nice example. So I will make an example. But before I do that, let me ask Chan and Tashan Chan. Do you have any comments, suggestions? Should I proceed? Okay. No, you should respond, by the way. You can unmute the mic, by the way. It's fine with me. Okay, why don't you solve a problem for me? There is this rotating disk. You have to do it, by the way. Okay. Oh, come on. Okay, this is the last time. I'm not doing it again. So this is the rotating disk. And there is some person who is standing. Where is this person standing? Let me make a decision. I can come up with a problem right now, by the way. Doesn't matter where is he standing. Okay, he's standing or she is standing at a corner. Doesn't even matter. And the radius is 0.5 meter of this disk. Radius is 0.5 meter. Okay, this disk is rotating at 0.524 radians per second. 0.524 theta dot is, come on, 0.5. Why don't you convert it into degrees so that we have a physical understanding? How much is it? 0.524. Oh, what happened? 0.524 radians per second, because it's, if I tell you this, for you, it's just a number. Convert it into degrees and just let us know. Is it even making it? Huh?
30.023.
Yeah, that's very physical. So the disk is like, the person is standing 0.5 meter from the center. This is a small disk, right? Somebody is standing 30 degrees per second is very physical. The whole thing is rotating. Okay. Did I miss anything? Okay, the person is actually walking. Oh, that's not good. This person is also walking. So let me show you the direction of his or her walking. She is walking towards the center at a speed of minus, 1 meters per second. Okay, I will not fill in the blanks. You will help me. The question says that if when she is walking inward, okay, I don't see the value. I think I have to come up with a number myself. So let me make it more interesting. As she is walking, she is accelerating. She is increasing her speed by 0.5. Okay, 0.1, let's do it. 0.1, because I am making this question. This question is not in your book. 0.1 meter per second square. And the disk is decreasing the theta dot as by a value of the disk is okay. The disk is decreasing. Okay, disk. How should I even explain it? My point is that as the disk is rotating, it is slowing down. Okay, the disk is slowing down. Okay, slowing down. Finally, the right English. At 0.1 radian per second square. Okay, and the disk is actually rotating clockwise. That is one crazy problem now. Okay, now let me draw a reference line for you, because otherwise everyone will get confused what is happening here. So I'm drawing a reference line for you, and this is my theta, okay? Okay, you have to tell me, and the problem is not ending. Find velocity of the lady and acceleration of the lady.
As a function of time or?
Oh, your question is, no, I will tell you why. You just write the formulas and automatically it will answer your question. I understand your question. Write down the formula for me first, velocity and acceleration. Then you will have those little symbols. Should I use a paper? I really encourage you if you can again. Because trust me, if you do this problem here. So the moment you write the velocity and acceleration formulas, trust me, it's a game over. Then the rest of the problem is figuring out what on earth are these numbers that I have written. Well, the last time I hit some, oh, it happened. Last time I hit some box here, then this vibration also stopped. Okay. Okay, first of all, let me help you a little bit because this is the first time you are even doing it. So the velocity is equal to VR plus V theta. Are you with me? Okay, then what was that? R dot ER plus R theta dot E theta, correct? Okay, look, the fact that I have made this yellow line has made the problem confusing. If I remove the yellow line, so should I even remove if I remove that yellow line, that's entirely up to you. You go with anti-clockwise as positive and clockwise is negative and keep on doing the problem. And another student can say clockwise as positive and anti-clockwise as negative, and you can continue with the problem. Right now, I will do this problem with the yellow line, okay? I have given you the yellow line. So the first part is, what is R dot? Yeah, as she is walking towards the center, right? So I think one mistake all of us are doing is we are not making the coordinate system. So let's make a coordinate system. If this is my theta, so, and what was that? That we need to have our angular coordinate in increasing theta direction. So this will be my increasing theta actually, because if this is yellow line, this is theta, the theta can increase in that direction, right? So this is my, it's very hard for me to make a drawing. Okay, E caret theta. What will be E caret r? Increasing r is, of course, in this direction. Are you getting my point? Yes, no? E caret r. So now give me the value of r dot, everyone. No, she's walking, she's increasing. No. Where is her speed, by the way? Did I even talk? 1. So 1. That's it. She is walking inward, right? And my E caret r is outward. My E caret r is outward. Okay, I think the coordinate system looks confusing to you, so I will make it again for all of you. This is your E caret r, and this is your E caret theta. Now tell me again.
0 minus 1.
Yes, good. So it will be minus 1 E caret r plus. What is r? Okay, I did not tell you r. No, I did not tell you. Oh, I did. Oh yes, no. I will explain. So yes.
So E theta and ER represent the coordinates of the rotating disk, right?
E caret r and E caret, oh, of course, E caret r and E caret
That's
theta.
why, because she is moving towards the center, it's minus because of the coordinate.
Because my radial outward is considered positive in this problem. She's walking inward, so she has a negative. Yes, I made a mistake. She's walking, she's increasing her speed. Find the velocity and acceleration when she arrives. When she arrives. 0.2 meter from center. Are you getting my point?
Yeah.
Okay, good. From 0.2 meter from center. So why don't you tell me the r? 0.2. No. From center. Your r is from center. So when she arrives 0.2 meter from center, that she has covered 0.3 meter. So 0.2 meter. Okay, theta dot. Where is theta dot? 0.524 radians per second. Hang on. The disk is going clockwise. My positive E caret theta is defined there. So I think I should put a negative 0.524 and E caret theta. I'm telling you, I have made the problem complicated by the yellow line. Next time I will remove the yellow line. Trust me, the problem will become 2 times easier. Okay, give me the acceleration. This one is, I'm telling you, is hard. Yes, please.
For example, we said that the radial velocity is -1, but she increasing her speed.
So that chunk will come here. Right now, I'm talking about the fact that she is going. Okay. Got it. Yes. Okay. I got it. Okay. I need to explain this. She's in. Okay. I need to explain this, everyone. Sorry. The question is, her speed is 1 meter. Find and her speed. Okay. Thank you. I will say her speed is 1 meter per second when she arrives at 0.2 meter. Okay. I will make this comment. Otherwise, her speed is, thanks. Her speed is 1 meters per second when she is r equal to 0.2 meter. Got it? Okay. Good. No, she hasn't started off from 1 meters per second when she arrives at that point. We are talking about everything at that particular point, r equal to 0.2 meter. Thank you. Good. Okay. Now tell me r double dot minus r theta dot square. This is definitely you are doing it. R theta double dot. What was that? R 2 r dot theta dot. This is you are doing it. Trust me, you are doing it. I'm not doing it. Yes.
Can we use the formula from kinematics to change this velocity and acceleration function as a position of as a position to as a time?
Yes, actually, I got your question. Actually, this thing is coming from that. I actually did not go over the derivation, so I took his or her position as a position vector. Then I took first time derivative. I got this big chunk. I had another time derivative. And then I took this big chunk. So this is exactly what you're saying. So your question is, can't I just make a position vector? Can't I take a position vector from the center of the disk to her and take first time derivative and second time derivative? That's your question, right?
Actually, I asked the fact that these functions that we are using right now,
Huh,
functions of position,
huh.
can we change them into functions of time?
But they are functions of time. There is a dot on top of them. R double dot.
Yeah, but
R double dot. It's a what she has is the R, her position is definitely a function of time. I'm telling you that it's increasing with time, so that's why I somewhere also gave her acceleration. So it is a function of time. The fact that I'm giving you R, definitely I need to specify the position, but it is a function of time. There are time derivatives, no? I will be covering the derivation of it somewhere down the line. Get it? Okay, I think all of you need to help me with this one. Let's play with this light. Yeah.
Sir, can you please explain why 0.524 is negative? The sign and conclusion.
I will explain. You know, the fact that I drew that yellow line has made life complicated. I am the one who drew the yellow line and said the theta is from that yellow line. Got it? So if you have that yellow line as the reference line, got it? Then you can see that the increasing theta, if I have to increase it, I want theta has to keep on increasing in anti-clockwise direction, right? And the fact that the disk is rotating clockwise, I am definitely going opposite to the increase of theta. Are you following me? So imagine that this yellow line is actually somewhere in the space and it's going clockwise, so that angle is decreasing. So I said, you know what, theta dot is negative. That's the philosophy. Oh, got it? But I am telling you, I made the problem more hard because of these things. Okay, you give me R double dot. Let's finish this. Give me R double dot. Oh, where is it?
0.4.
It's hard for me to even find this so much English. She is increasing her speed by 0.1. Okay.
Negative 0.1.
Oh, you figured it out? Okay, so he figured it out. It is minus 0.1. You know why? It says she's increasing her speed. Now follow me. She is traveling inward, right? And she is increasing her speed. The word increasing should not bother you. Oh yeah, it's increasing. So why is he saying negative? No. Because the fact that she is traveling inward and your R dot was negative, so your R double dot will also be negative. Even the word is increasing. Okay, minus. Give me the R. The location is, oh, you know what? Now I understand why I have to remove this. Oh, sorry for that. She started off her journey from 0.5 meter, but I am interested in her. Oh, now I understand why everyone was saying 0.5. Sorry for that, everyone. So let me use the word that I understand. Oh, so radius of the disk is 0.5 meter, but I am interested in her location at 0.2.
So 0.2.
0.2 again, as previous. Okay, theta dot square.
0.1.
Oh, no, it's given 0.524, I think, with a negative. Should I increase the color? Okay, minus 0.524 square. Oh, come on. So then I will put a bracket. And then I will put E caret R plus. Okay, give me the R again, 0.2 meter. Then what is theta double dot? I have to figure it out. The disk is slowing down at 0.1. Now hang on. This disk is slowing down. You remember my theta dot was negative. That's fine. Now it is slowing down at 0.1. So I will put a positive 0.1. I will think again about it. I'm pretty sure, by the way, plus, then I have 2 r dot is, I think we said negative. But what was that, by the way? -1. Okay. And theta dot was minus 0.524. And then I have put a e caret theta. Yes.
This negatives comes from the references, right? For example, in minus 0.1, minus sign
Okay.
comes from
Huh.
the reference.
I will tell you. I will make it easy for you. Because of the yellow line, the moment we said that theta dot is equal to theta dot is negative, right? Theta dot is negative. Okay. So no, I will tell you. Theta dot is negative. We initially figured it out. So clockwise is negative from in this question. If clockwise is negative and the question says the disk is slowing down, if the disk is
Acceleration must be
in the opposite direction. Yeah. Did I make a mistake? Hang on. 2 r dot theta dot. Theta dot is negative. That's fine. Where is theta double dot? Theta double dot is positive because when the disk is slowing down, that means that slowing down is in the anti-clockwise direction. My clockwise is negative and my anti-clockwise is positive. Yeah. Where is it? 2 r theta double dot, and my theta double dot is this one.
And the R double dot, we said minus 0.1, right?
Where is r double dot one?
In acceleration, R double dot, we said that minus 0.1 in blue.
Okay, r double dot is minus 0.1. Okay.
The reason is she's increasing her speed towards the center.
She is increasing her speed by 0.1. So, okay, she is increasing her speed
Towards the center.
So she's walking inward. So that's why there is a negative 0.1.
Because the reference is towards
Outward.
because of this.
Okay, should I do this problem again?
I think a quick rundown will be.
Okay, I will do it very quickly. So let us make a box. Let us make a box here. And why don't you all just follow me one time here? Let me make a box. Okay, so I am just putting these things. R dot. She is walking inward, so my r dot will be negative. And what is her speed that I gave you? 1 meters per second, negative 1 meter per second. Inward, done. Okay, r double dot. She is increasing her speed by 0.1. So of course she is going inward and she is also increasing her speed. So that definitely means I will put a negative point.
If she was decreasing her speed
To positive.
and moving inwards,
Positive.
that means it would have been positive.
So r double dot would be positive. Okay, then I have theta dot. Now, because of this yellow line, decreasing angles, so I have clockwise here. It means negative because my angle is decreasing. So theta dot is negative 0.524. Don't get confused. Why didn't you put a negative here? In an exam setting, I will just give you the value of theta dot. You have to figure out positive or negative. So this is definitely negative. Then I have theta double dot. The theta double dot, it says that the disk is slowing down at 0.1. So you can see that my clockwise is negative. So slowing down means my theta double dot is positive. So positive 0.1 radians per second square. Good? Done? Okay. No, yes, confusing. Okay. Okay, we still have 10 minutes. We have a couple of questions in your homework, by the way. I made them like this, so you have all the time, you can figure them out. Or probably for this theta, I can just make the drawing a little more intelligently, like it's like this, theta, 90 degree. This is again 90 degree. You can make this or this, anyone reference. Okay, so, okay. I think I'm about to do entirely different problem. This walking inward outward is enough. The question says that I have some fellow, this is our radar. The fellow is going like this. This is flying nice and beautiful, like this one. So for my radar, I'm making this line. And this angle is theta. This is my reference line. It is going with a velocity v. And after a while, it has arrived here. Okay. The question says that once it has arrived here, do a control Z. The new theta is this one. The question says that this is my R. Let me use a pink line. 6,400 feet. R dot is 312 feet per second. Then theta is 40 degree. And theta dot is negative 0.039 radians per second. And R double dot is, everything is given. Come on, this question is nothing then. Feet per second square. Theta double dot is 0.003807 radian per second square. Give me the velocity and acceleration. After that question, this looks so easy. Do it.
Just to be sure that all 3,400 feet is the position of the yellow one, right?
No. Oh, hang on. That's a good question. Hang on for a second. That's a very good question. Theta is also given to me as, yeah, thank you. You are right. Actually, theta is 40 degree. I think you are right. So of course, we are talking about this position. So okay, the R was here and R became like this, but now I'm talking about this R. Thank you. Thank you. So now give me the velocity and acceleration at this position. Good. He's right. Okay, first step, give me the coordinate system. Why don't you make that E caret R and E caret theta? Why don't you just show me your coordinate system? Let me, I just need to see those two arrows. So your E caret theta is in which direction?
Towards this direction.
No, E caret theta will be in the increasing direction. No, that is a good point that I have to make. E caret theta is in increasing theta direction, everyone. So my E caret theta will be
Upwards, right?
it will be like this. Where are my notes? Okay, notes vanished. Let me make it myself. Increasing theta. Okay, what about E caret R? Increasing R, right? Okay. Why don't you tell me why is theta dot negative in the question?
Because they decreasing.
Oh yeah, absolutely. Because the plane is going in this direction. So your theta is decreasing as the plane is going towards right? That's why your theta dot, if you see, its value is given to you in the problem with a negative. Because theta dot is negative because the plane is going towards right. So theta keeps on decreasing, right? The theta keeps on decreasing. You have to do square of this plus square of this, the whole under root. You will get the magnitude. Then square of this plus square of this, the whole under root, will give you the magnitude of the acceleration. Why don't you, you still have 3 minutes. Can you please double check? It's a number crunching problem, so. Look, it's very easy, if first, let's say if anti-clockwise is positive, let's say, no problem, radial outward is positive. The disk is rotating anti-clockwise, that's a positive value theta dot. The disk is decreasing in its rotation speed, so theta double dot will be a negative, right? Because anti-clockwise was positive. So if it's moving radially outward, that's a R dot with a positive. If it's also increasing its speed in going outward, then R double dot is a positive. So think like that. Your battery is running low. Why is that? Didn't I? Oh, it's not working. Oh. Do we have anyone who solved this, by the way?
So in this case, the angle will be increasing, so theta dot.
No, angle is not, no. The plane is,
right? The reference is what? So
Huh.
at first, it was traveling.
it has been traveling towards right. It was in the pink position. It arrived at the yellow position. So it goes like,
At first, it was at the pink position. Oh.
so at first it's at the pink position. It goes to the orange position. Theta has been decreasing. So theta.
Okay. No.
No worries. Okay, so I will actually. Did anyone got this? 399.5. Sure.
Yes.
And what about 19.5? Okay, everyone. So just one quick remark. Why don't you do this problem? For example, why don't you do this problem yourself? and do this problem when, hang on, listen, why don't you do this problem when the person is not walking? When the person is not walking, why don't you do this problem? When the person is not walking, what will happen? You will have R omega, you will have V equal to R omega because of the fact that the disk is rotating and the person is standing over the disk. And when the person is not walking, you will have accelerations, two components, R omega square and R alpha from your physics one. Are you getting my point? Why R omega square? Because at the end of the day, the person is standing on the disk is rotating. So his body or he will experience a normal acceleration, right? Because of my physics one. And why tangential acceleration? Because the disk is rotating. Okay, everyone, bye-bye. If this is not clear, you are always welcome for office hours. For this one? For the next one, I will. Thank you. 399.5 and this one. Why are they coming in zero? Hang on. Do we have any questions from? Okay, nobody's here. Let me pause the recording. Then I think there is some mistake here. I think this will be V equal to 6,400 feet into minus 0.039 radians per second E theta is 312 feet per second into E caret R. And this will be equal to 2 into 312 into minus 0.039 plus 6,400 into 0.003807 into E caret theta plus 9.751 minus 6,400 into minus 0.039 square into E caret R, which comes out to be equal to 0.0288 E caret theta plus 0.0166 E caret R. Correct? This is E caret theta, E caret R. And the units are in feet per second square. Correct? This is our A. And I think no need to write V. Okay, you can find the V magnitude yourself. Do it yourself. So this is your answer. This is your V. E caret theta. Okay, and then this is your A. How many agree and how many disagree? This is your A. Okay, everyone. Thank you. V and A magnitude you can find yourself.